Let's take a closer look at the standard normal curve, which is kind of a specialized normal curve. Or if you want to think about it, it's the least special normal curve, and every other one is specialized based off of this. Whatever. Anyway, it's a normal curve, so it has the same distribution as a normal distribution. It's symmetric, but it has the mean as 0 always, and the standard deviation is always 1. If that's the case, then the mean, the median, the mode are all 0, which is where the highest point is. The inflection points happen at 1 and -1, respectively. The area under the entire curve is still 1, each half is still a half, etc. All the other properties of a normal distribution are still true. All right, but the standard curve, of course, it's also called the z-curve a lot because it's made off of z-scores, i.e. standard scores. All right, so we are going to find the area under the standard normal curve to the left of z equals -0.38. Now I drew these for you. I'm of course going to shade them in with my computer. You would shade them in yourself by hand because it's kind of a pain to shade by computer. So I want the area to the left. So let me pause and get that drawing for you. There it is. So here's -0.38 here. Notice it's not even quite halfway between 0 and -1. And it's to the left, so it's over there. Now the question is, how do you find it? And the answer is Excel. So let me bring Excel up. Hold on. Since I'm going to need Excel so much, I'm going to make it so that they're side by side. That way it'll be easier to follow. Okay, so let's look example 1A. All right, so I want the area to the left of -0.38. Now the way you do that, hold on, make this bold so we can see it better, is you're going to use the functions that are standard issue inside Excel. So Excel has the normal distribution function. You just got to know what you're doing. So you type equals norm. All right, now in my version, I have Excel 2010, so it's norm.dist, okay? If you have an older version of Excel than 2010, then just plain norm.dist. It'll work the same either way. So norm.dist or norm.dist, either one. And then it says, what's the x value? Well, the x value for us is -0.38. The mean is 0. Standard deviation is 1. Again, because we're working with that normal curve. And then it's saying cumulative, and we will always use true. And there you go. So the area that I shaded over here is worth positive 0.3520. 20 because the 7 would round the 9 up, and they wanted 4 decimal places, which is actually pretty common with probability questions like this. So they'll want 4 decimal places. All right, cool. Now what about the next one? The next one, they want the area to the right of 1.25. Well, let me go make that drawing again. Hold on. All right, there's the drawing. So the difference here is that this is not to the left anymore. This is to the right of 1.25. Now I know you're thinking, what difference does it make? It makes a big difference because the Excel function standard issue finds left probabilities. That's how that function works. So if I type equals norm dist or norm.dist, either way, 1.25 comma 0 comma 1 comma true, oops, I typed that wrong, it gives me 0.89. Okay, well, let's look at this for a second. There's no way that this area shaded is 0.89. I mean, the whole curve is 1, for the love of goodness. So what have I really found here? What I did was I found the area to the left of 1.25. That's what Excel finds, right? All this white area right here, that's 89%. So then the area to the right, which is what I was actually looking for, will be equal to 1 minus that, right? The complement, which is 0.1056, which makes a lot more sense because that's not a whole lot of area that I've shaded there. All right, now for the next one, it's to the left of that and to the right of that. I'll make the graph, and I'll see you here next time with that graph pre-drawn.